This is being built for my partner in crime, Mike Smith, out in Pennsylvania. Mike and I do the Tech Vets podcast, and I built Mike's original, well, the computer he's using now. I built that back in March of 2015, and you can see that original build video down in the video notes below this video. There are links to things I'm going to be talking about, including that original video from 4 years ago, nearly 5 years ago. And this is going to be the beast. You'll see here we've got a Core i9 9900K. We're going to be cooling it with a Mugen 5. We've got a 970 Pro Plus 1 terabyte super fast drive. 64 gigs of RAM in this box right here. It's all going to go into a Z390 Aorus Pro Wi-Fi. Now, he doesn't want the Wi-Fi, but believe it or not, this was cheaper for the Wi-Fi version. It was on sale. We're going to power it with an RM750X modular power supply from Corsair. Now, Mike has a DVD drive and a couple of hard drives and I think an SSD in his current rig that he's going to move over along with his GPU himself when he receives the computer. Yeah, this is going to be a very powerful build without going over the top. There was some discussion. This is the 9900K. There was some discussion of going to the KS. So the KS is a limited edition processor. They're on Amazon right now for about $629. There's about $60 in sales tax. It's about $680. And it's really not much faster than this. More overclockable. If you're into overclocking, it's desirable. Or if you're a collector. So bottom line is, money was still a factor in this. Mike wasn't just throwing money for the sake of money. He wanted performance. So I said, well, you can get the KS for about $150 more than this. I don't think it's worth it. It's worth $30 more in reality, in my opinion. So he said, okay, 9900K. Mugen 5 cooler. He wanted for the same price as this 1 terabyte Samsung, he could have got a 2 terabyte Intel, but this runs twice as fast. He said, I want the speed. No problem. We got it. And it needs a good beefy power supply to power everything. And Mike was a little concerned about that. Mike's running a 1060 graphics card, which for the types of videos and audio production that he's doing is just fine. It's overkill, actually, for what he's doing today. And he'll be easily able to swap that out. And then I'll be able to ship this without any concerns because there's no graphics card in it, you know. So when it ships via FedEx from Phoenix to Philadelphia, there's nothing in there to break free. All right. So first thing we're going to do is get the motherboard out of the box. And we'll set that down. I take this cardboard out, and we'll just, now where's Lyle when I need him? I got a box for you, boy. And then in the box, you'll see we've got some temperature sensor, some documentation, another temperature sensor. I don't use those. There's the antenna for the Wi-Fi. There's a screw for the M.2 drive. There's a standoff for the M.2 drive. SATA cables. So Mike's going to want me to cable all this for the graphics card and for the SATA drives that he's going to be adding. He doesn't want to do any cabling. So I've got to remember, after I get everything set up, to add the additional cables for the drive. So all he has to do is open the computer, plug the cables in. The drives install toolless. You know, there's no screws required to install 2.5-inch or 3.5-inch drives in this Corsair 200R case. And run the cables for graphics power, or the cable. And then I'll have to wire tie those up a bit so they don't slap around while it ships. And it should make his life real easy. All right, time to get the motherboard out. Don't need that. We can get this plastic off of here. Really enjoy seeing the I/O shield is already part of the motherboard, so we don't have to install this rectangular piece separately, like we often have to do on lower end motherboards. I was going to say cheaper, but this one wasn't that expensive. We've got heat shields for the M.2 drives here and here. And I think that's where I'm going to start, is I'm going to put the M2 drive in first. I got this new screwdriver the other day. I ordered it from Amazon. This is supposed to be, I think this is supposed to be one of those JIS screwdrivers. And I'm wondering, because it doesn't look any different. Ooh, it does actually bite in there pretty good. And it's magnetized. That's the first time I've used it. I think it's in my Amazon store. If not, I'll have to add it. And the link to the Amazon store is in the video notes below the video. And if you buy anything from Amazon, anything at all, but it's my link to the Amazon store that took you to Amazon that led to your purchase, the channel gets a small commission of whatever you buy. You don't pay any more for it. It's another great way to support the channel. Underneath this heatsink, there's a piece of tape that protects this thermal. There's like a thermal tape here to help transfer the heat off of the SSD. Now I could put the SSD here or here. I prefer to go up here, but this is a, on some motherboards, this slot is faster. Sometimes this is a ×4 and a ×2. On other motherboards, they're both ×4. It just depends on the board. But generally the top one is always ×4. Also, this is a harder area to get to once the graphics card and the heatsink are in place. So getting to this after the build, like if you use this one first and then later on you want to add a second one, it's harder to add the second one here. If there's one already here and this one's empty, no big deal to slap another SSD in there and you're in and out in a couple minutes. This is the fastest solid state drive you can buy. It's also one of the most expensive. This is $200. Now, other 1 terabyte NVMe drives start under $100. So why is this one so much money? It's fast, fast, fast. It's got a great warranty. And you get the Samsung Magician software, of course, with all Samsung SSDs. Another contribution came in from Ronald Hambrick. Thank you, Ronald. Now, when you open up the Samsung packaging, it's a little weird the way they package this. If you take this plastic lid off, this is our 1 terabyte M.2 drive. It's still got to get used to holding it so I can see it. There it is. Won't focus, but that's it. And I'm going to just gently, I'm going to put it back for a minute. I'm not ready yet. What I wanted to show you was there's more in here. If you look on the package, there's a little indentation, and you can pull the center out, and that's where your documentation is. Not that we're going to use it. Now we can get rid of it. So now I can take this little standoff that came with the motherboard. There's 2 of them. I'm going to just open this up. And we're going to get that little standoff out of there. And we're going to put the standoff right here in the position marked 80. That's 80 millimeters from here to here. I'll just start it with my hands. And then we can tighten it down. It's kind of hard to tighten with the Phillips. Maybe I can use a straight edge. Do a flat screwdriver here. Don't over tighten it, but you don't want it too loose, because if you ever have to take the screw out, you don't want the screw to back the standoff out with it. Not that that would be the worst thing in the world, but nice to avoid that scenario if you can. Now I can take the 1 terabyte drive. Label faces up. It's going to go in a bit on an angle. I don't know how well you can tell, but I'm going to put it down on an angle. It's going to line up with the socket, and I'm going to push it straight back. And you'll feel it sort of bottom out against the back of the connector. And you'll see it's kind of springboarded at this point. Can I zoom in more? Let's see if I can zoom in more for you guys. Oh, that's the wrong direction, Carey. Okay. And in this bag, that's included in the motherboard box, there's a little tiny screw. We need to get that out. Be very careful. These are very easily lost. They can be difficult to find. Let's see if that fits on the end of this driver. Ooh, nice. Who knew? Now this screw, all it does is secure the drive in position so it doesn't fall out. So there's no reason to over tighten that screw. Just get it snug, you're good to go. That's 1 terabyte of storage installed just that easily. It's really, not exaggerating, that's just how difficult that was. All right, let's get rid of those boxes. And let's back this camera back off. Man, what an awesome camera guy. All right. I think I'm done with these scissors. Now we have the heat shield to put on. So I guess I was premature in pulling the camera back. So let's do this again. So when it comes to putting this heat shield on, we've got to remove the tape off the bottom. And immediately after removing the tape, don't remove the tape until you're ready. There's a very small slot. Don't put this tab above where it's contacting the circuit board of the SSD. It's got to go above. There's a little slot right there. And then it'll be a little tacky with that tape. And then we'll take the screw that we removed. We'll put that back on the end of the screwdriver. Make sure that's aligned so that the screw will go in. And again, just snug is all you need, and that's going to lock that right into position, and that's going to make sure everything runs nice and cool. Heat shields are not required for M.2 drives. They're nice to have. Sort of a smoke them if you got them, but it's not required unless you are an extremely intense user doing an extreme amount of writing to your drive, in which case you don't need me to tell you because you already know. Okay, let me just set this aside and figure out how to open this Dungeons and Dragons dice. I see a piece of tape right here. So that piece of tape just holds the label together, and if you want to see the codes on this, we can bring that up. Let's move it this way, get out of the light. That's our CPU. And the knife. You'll see that just opens up like that. Because everybody needs one of these in their life. Okay, now how do we open? There's a piece of tape here. There should be one on the exact opposite side. Yep, there it is. There it is. And somehow we separate Darth Vader's helmet. Come on out, Anakin. I know you're in there. I'm so glad they made this so easy. By the way, installing this chip would already have been done. Getting it out of this box is the biggest challenge of this entire process. There we go. It's cracked. Should I separate the white from the egg yolk? Boy, I hate to see what this came out of. There it is. See, they could have just shipped it in this. There's nothing fragile here. There's no reason they could have just take this. I feel like I should mail this to Intel CEO, and every time I get one, just like AOL installation discs from the 90s, just keep mailing this to his house until he gets the hint. Just bury him in these things. Absolutely one of the dumbest marketing moves, right up there with New Coke. But at least, unlike New Coke, what's in it is good. So this is the actual processor. And you see, there's not a whole lot to it. There's no reason. There's absolutely no justification for this packaging. Installing the CPU, super, super easy. Let's get you zoomed back down. So here on the motherboard, we have this area. It's got a plastic cover over it. We're going to just push down on this lever and pull it up. And we might have to help this up. Now, this little socket contains 1,151 delicate pins, so it's important that we don't touch them or make any contact with them. That's why that cover is there. So now we can get our CPU out of the box. You'll see there are cutouts. These little half-moon shapes, these are for your fingers to go in, so you can take the product out. There's your documentation. There's your Go Faster sticker. If you put this on your computer, it'll go faster. Hey, you ever seen a car win a race that didn't have stickers on it? That's all the proof you need to know. Stickers make things go faster. All right, there's our CPU. That's our 9900K. This is going to be Mike Smith's new brain for his computer. So every time you listen to the Mike Tech Show or watch a Tech Vets that's been processed or visit MikeNation.net or TechVets.com, you know that you saw the video for the machine that's creating all that starting in probably maybe later this month. So again, there's a little cutout in the plastic for you to be able to open this easily. And if my camera will focus, there it goes. Get my thumb underneath that. Now, I don't want to touch the surface or the bottom of the CPU. And there are cutouts in the plastic container on each side so that you can hold it properly and remove it properly. And this is also another reason why you don't have to wear an anti-static strap. If you hold your parts properly, there's nowhere for static to go. There's a little, there's a little cutout in each side. There's one right here where my fingernail is. And exactly on the opposite side, it's a little lower or a little higher, I think. Is it there? Yeah, it's higher. And that prevents you from installing this the wrong way. There's also a little gold triangle right down here in this corner. And there's a white triangle right down there. And you line those triangles up. And so what I do is I gently set the processor, lining up the two triangles. I lean it in like this, and then I gently let it go. Once I get it as low as I can get it and let it go. It'll drop about a few millimeters. And then I grab the edge of the heat shield and I just wiggle very lightly. Don't put any downward pressure. I'm just lightly seeing if it'll twist. If it won't twist, it's in the socket correctly. If I had better eyes, I could probably look more closely at that and tell by looking at it. But I don't, and so that's how I check it. But if you put downward pressure on this chip and wiggle it, you'll bend the pins. So if you're going to wiggle it, literally just wiggle it. Don't put any no downward force. The reason is, the way this chip installs, if we back the camera up a little bit here, is through downward force. You see, this lid's going to come down, and then when this lid comes down, it's going to lock itself underneath that screw on the board. And as we bring this big lever down, this lever is going to add a lot of pressure and force that heat sink down. And it pushes the whole socket down so the pins come up, which makes them extremely vulnerable. This little plastic protective cover is going to automatically pop off. So I'm going to put a hand, let's see if I can move this. I'm going to put my hand on the big plastic I/O area. If your I/O area doesn't have any plastic, it's still okay. You put your hand on top of that. That's all grounded. No worry of anti-static discharge. Then I'm going to grab this handle, and I'm going to pull it down. And there's a lot of resistance. Keep pushing it down and slide it underneath the catch. And this did slightly come up. This plastic lid didn't come up all the way. That happens sometimes. If I show you on the side, you'll see it kind of started to pop up. If it doesn't pop up on its own, it's now safe to just grab it and pull it up. Save this piece. Your motherboard warranty will require this is put back in before you ship it back to the manufacturer. If you ship the board back to the manufacturer without this, your warranty is void. All that we have remaining is the cooler and the RAM. Now if I put the RAM in, they go in these sockets. We're going to use all 4 sockets, and it's going to get in the way of installing the cooler. So I guess it would make sense for me to at least start the cooler install at this point. So for that, I'm going to move the board out of the way, and we're going to grab today's cooler, which is the Scythe Mugen 5. So the Mugen 5 works with AMD and Intel processors, all of them really, except all of the ones currently sold at retail, except Threadripper. This works with all of them but Threadripper. Inside of the box, I'm done with that. This is our documentation, and you'll see the documentation is very simple. It's 1 page for the LGA 2011 and 2066 Intel CPU. It is 1 page for the LGA socket 775, 115 anything, and 1366. And it's 1 page of simple instructions for all of these AMD sockets, which include AM2, AM2+, AM3, AM3+, AM4, FM1, FM2, and FM2+. So yeah, it's pretty well got you covered. But if you watch my channel, you know we don't need these, so we'll just put those over there. In this bag, stuff that. We've got these, I call them wire hangers, and they're used to attach the fan. Now this heatsink, you can add a fan on the front and a fan on the back. We're only going to use 1 fan, so we don't need a pair of these. So the customer will get that in case they want to add a fan later. We have a tube with thermal compound that's good for about 3 applications. Unlike other manufacturers, they give you a little plastic bag you got to cut open. You can put this in a drawer and use it months later. Save it. You know, what's remaining of it, you know, from what we use today, there'll be plenty left. These bent brackets, they kind of look like parentheses. Those are for AMD sockets. We're not building AMD today, so we don't need those. This little bag contains those standoffs and screws for adding the additional fan, including little rubber anti-vibration dampeners to go on a secondary fan. We're not putting on a secondary fan. We don't need that. See, this installation's getting easier and easier, isn't it? These are used on Intel sockets, these 2 brackets. We do need the back plate. And then in this bag, there are 2 sets of standoffs, big ones and little ones. We don't want the little ones. The little ones, see, there's a big one and a little one. The little ones are used for sockets 2011, 2066. And on those, you don't even need a back plate. It's even easier to install. So those 4 standoffs we don't use because we're not installing an Intel socket 2011, we're not installing an Intel socket 2066, and we're not installing any AMD. So therefore, all of these parts can go in a plastic bag. I put them in a Ziploc bag and give it to the customer. I'll put the documentation in there and I'll get a Sharpie and I'll write cooler across it. So if the customer ever, I don't know, wants to change the cooler out and use that cooler on somebody else's system that's AMD, they have all the parts to do that. Or if they want to add the secondary fan, they can do that. And what we're left with now are the actual parts we need. And that is these 4 screws, the 4 screws, 4 standoffs, 2 brackets, back plate, thermal compound, fan hangers, fan, cooler. That's it. Okay, so I got to get this back plate installed. And I think I need to sort of step over here. I got to figure out how I want to do this. This is going to be a little bit difficult to film. You might want to watch the corner video as well, just to get all the angles. Because what I have to do is I'm going to pick the board up, and you'll notice when I pick the board up, move the board down. When I pick up the motherboard, I'm going to grab it where there are no metal parts. So I'm grabbing it by plastic and by this back I/O, which technically the back I/O is metal, but it's not part of the circuit board. And I just want to set it up on its edge because I need access to this back area. And I'm going to take the back plate, which is metal, it's not plastic like other cooler manufacturers cheap out on. And it's got 2 holes in the back plate. And those 2 holes align with those 2 screws right there. So we're just going to set that right over it with the rubber pads against the motherboard. We want the rubber pads against the motherboard. Now there's 3 holes in each corner. And for socket 1151, we use the middle hole. So what I'm going to do is just hold that in place. And again, I want you to notice I'm not touching anything silver on the back of this board. I'll put my finger or fingers on the back plate to hold it in place. I'm going to put my thumb on the edge of the board. Wearing an anti-static strap now becomes irrelevant because if there's a static shock, it goes through the back plate or it goes through the edge of the board. There's no harm in any of that. It's sort of like touching a doorknob. It doesn't hurt anything. If you want to wear an electric static strap, I'm not against it. I just don't wear one because I know how to handle the parts properly. Now I'm going to turn the board over and I'm going to grab one of these standoffs right here. And I'm just going to pick any corner. I suppose this one's the easiest. Start with the easiest one. And we need to make sure that it's being aligned with that middle hole. There it is. I can see it poking through. And I just want to give that a few turns. Righties tighties, lefties loosies. You had a terrible view of that, and I apologize. Then we're going to do the opposite corner. And the reason we do the opposite corner is when this is locked in position on these 2 sides, then these 2 sides are then automatically by default already aligned, and I don't have to hold it with my hand anymore. So same thing, I want to make sure that this is flush against the back of the board or it won't reach, and that as I tighten it, that it's coming through the center hole, and it is. So now I can give that some more turns and set the board down. Now I can bring these down a bit more with the included driver. I don't want to tighten them all the way, but I can turn them a few more turns. And like I said, this is super easy to put these last 2 in now because the back plate is all aligned properly. Now that they're all started, I can tighten them down. It's good to do opposite corners. It's good because you want that back plate to be completely flush. It's possible if you tighten one side and then the other, you end up with a warp. It's nothing that your eyes can really see, but it can affect the way the cooler sits as well as the performance of the cooler. So it's very simple to do this stuff. It's just these little details you got to watch for. And as long as you know to watch for them, they're super easy. And I'm going to just keep going around and tightening this until I feel like I'm getting, you know, these aren't wanting to turn without significant force. You don't want to use too much force. You can crush the motherboard. So I just keep dancing around it. Sometimes as you tighten one screw, another screw loosens, so I'm looking for a little consistency in how tight they are. This is really feeling good right now. That's, yeah, you see they're barely moving. That's what I'm looking for. That's it. Next, I can put the brackets on. So these are the brackets, and let's see if I can zoom you in a little closer with this camera here. Sound effects of the zoom. There we go. Perfect. These are going to go on. You see where this lever is that we moved to get the CPU in and out? This is going to go right over that lever. With it's got a little ridge that goes up. It doesn't go down. This would be wrong. This is correct. This is wrong. 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 And this is wrong. The right way, it's just like that. So again, little details, super easy. Now using the screws that we have right there, you see these long elongated holes. They're for different socket types. Just get this started. I think this goes towards the inside if memory serves correct. So we'll go towards the inside of that last hole, towards the bottom. Come on now. There we go. Got a few turns. Don't tighten it yet. other side. There and there. Oops, that screwdriver bites in there really good. Now we're gonna do the exact same thing facing asymmetrical. It is symmetrical, not asymmetrical. They face each other. It's like a mirror image. And then we'll grab those last two screws and we'll secure that. Once again, I want to be on the bottom part. Just get it started. That way we can still move it around nice and easy. It's super loose. That's it. So that pretty much preps our cooler for installation. All we have to do now is apply the thermal compound and attach the large cooler to it. The cooler's already got captured screws here and here that are going to go right through that center hole on each one of those brackets. That's how easy this cooler is to install. So before we get to that though, this may be a good time for me to put the RAM in. And I'm thinking about this right up in this corner. This can be a real pain to try and get to this a point with a screwdriver. These two connectors for power can be very difficult to access, especially in the Corsair 200R case once the motherboard is installed. So because this is a modular power supply, I can go ahead and connect the cable before I install the board. Sometimes I wait to install the heatsink because if I put the board in without the heatsink, I can reach over with my hands and plug in the cable to that area right there. But if I put the heatsink on, then the top of the case is there. It's almost impossible for me to get my hands in there. So I'm just thinking ahead and thinking out loud. We're going to be okay on this build. All right, so I'm going to take the lid off the thermal compound, and we're going to put a dab of it. Just trying to imagine how much it would take to cover the surface. That looks pretty good. And there's still plenty left in this tube. So we'll put the lid back on there and we'll put this back in the Ziploc bag for the customer. And then I'm going to use the finger on the glove and I'm going to finger paint. I don't want to be able to see the silver when it's completely covered. And some people have made up stuff about air bubbles and stuff like that. And those people are what we call hypochondriacs. But what you can do if you are curious about air bubbles, one of the ways you prevent them is by not making the thermal compound smooth. By tapping on it and making it tacky, you create these little mountains and valleys. And so, look at that. Pretty simple solution to that problem, right? Now you can see I've kind of got some thermal compound here. I'm going to wipe that off. Not that anybody's going to see it. Nobody's ever going to see that. But that's the kind of guy I am. That's the kind of detail I'm looking at. And the quality that I put into my build. And you see all the thermal compound I got on my fingertips there. Trying to find. You can even get a little Q-tip or paper towel or something like that. And now, take the glove off. You have to watch the top corner for that. And I turn it inside out, and then that'll just go in the trash. So that is a very inexpensive and good way to install the thermal compound because I can guarantee that my internal heat spreader, my IHS, or the top of the CPU, has equal coverage across the entire surface. There's not too little, there's not too much. When people compress down the thermal compound that's in a dab, there's no way to know until you take the heatsink back off again if you've got enough, too much, too little. Isn't it just weird that it works no matter how big or how little of the pea size? So that's why it's not that critical. This just makes my OCD happy. I know with confidence, I don't have to wonder. Did the refrigerator light turn off when I closed the door? I gotta know. Is my thermal compound completely covering my CPU equally across 100% of its surface? I have to know, okay? I've been doing this for 30 years, guys. This works. But so does the dab method, and so does the lines and the X and the dots. They all work. So let's argue about it. So here I've got the heatsink, and remember I said it's got a piece of protective tape keeping any dirt or oils from your skin on the bottom of this. So you don't want to remove this until you're ready to install it. We are ready to install it, and so the tape comes off. Now, you'll see one screw is sort of underneath the heatsink, and the other screw sits off to the side. This screw that sits off to the side goes towards your RAM. So we're going to set that down right like so, just right on top. And you'll notice I didn't put any thermal compound on the heatsink. The thermal compound goes on the CPU only. Now what I'm going to do is just turn this screw a couple of times through this hole on the top using the included screwdriver that Scythe includes with the $49 cooler here. We'll find that screw and we'll get it started. Once they're started, we can give them a couple extra turns, and we want to equally turn them. So we go 1, 2, 3, 4, 5, whatever, it doesn't matter. Whatever number you count to the same number on the other side. And then if you want, you go a couple more while you're there, and then come over here. And 1, 2, 3, 4, and go back over here. This one's 5, we'll come back over here. 2, 3, 4, come back over here. Oh, that one's already locked down. These do come to a dead stop. And you don't have to be exact, you don't have to be precise. You just want to try and level them, have them seat down relatively close to each other so that one side doesn't tighten and it causes that same warpage. It's the same reason when you put on a car tire, you tighten the bolts in a star pattern, you don't go around in a circle. Or the rim on the tire can get bent to one side, and you can't see it with the naked eye, but you feel it when you drive. And generally it means a new rim when that happens. So it's a similar concept here. Now, this is what the heatsink looks like installed. It's beautiful. Our fan is going to go on the side with the RAM. So we take the enclosed fan. This part of the fan that's exposed, that has the label that spins, this is the side that draws air in. On the other side, you'll see we have these support brackets, and as the fan turns, this label doesn't move. That's the side air comes out of. And what we want to do is we want to draw the air in this side, from the side of the RAM, and we want to push it out through the back of the case where we have our I/O ports. We want the air coming out this way. And there'll also be a fan on the back of the case moving the air in the same direction. We don't want fans pushing air against each other, or you end up with just a dead spot where it's going to get really hot. Now, using these enclosed brackets, I can already tell I want this cable to come out of the bottom right corner so that when I put this on here, this cable will go a short distance right onto the motherboard here. So if I put this on this way, I got to run the cable around, and I don't want this cable to ever interfere into this fan. So I want the cable to be as short as possible, to run the shortest distance, right? And that's going to make everything look clean and avoid any sort of interference from the cable into the fan. And so we're going to take the enclosed wire hanger and we'll just place it right through these holes you think are for screws. And as you can see, the wire hanger goes on just like that. And we'll take the other one and put it on the opposite side. Again, that's what it's going to look like. It's very simple. It's very simple. The top of this heatsink has little grooves in it, and the fan will align in the grooves. You may have to pull back on these little wire hangers. The fan will fit right in there perfectly. You see that? Isn't that incredible? That is what we call engineering. Good engineering. So what I'm looking at right now, I want to pull back on this hanger too on the other side, so that that sits flush in that groove. There should be, this should be flat. One side should not be raised up. So take a look, make sure it's straight. And then grab one of these wire hangers with you. I'm going to use my thumb and my hand, and I'm going to pull it and lock it into that spot. I have to hold on to this fan right now or it'll swing open like a door until I tighten the other side. So let me spin this around so you can see me do this. You wouldn't spin this around when you're doing it, but you're not making a video. Okay, so there's the other side. I'm going to grab this side, pull it back. That's not in all the way. There it is. And as you can see, Fan is nice and level. And it sticks up a little bit. That's what it's supposed to do. Now this is a good opportunity to wire tie, to take these wire ties off and to replace it with a nylon zip tie. I think we'll use 2. And I got these cutters. So all these cutters, all these tools, everything you see, the mouse and keyboard, everything I use in my videos is all in my Amazon store. This is where I bought it. You can buy it from the same place and pay the same price. These wire cutters, love these. I think these are Italian. These are fantastic wire cutters. I mean, these are the best. And I use these to cut the pigtails off the zip ties. Now this cable, you can see, is already folded, and I'm going to leave it exactly the way it is. I'm just simply going to put a wire tie in each side. I mean, nylon zip tie. Now I can cut these pigtails off. I want to get them as flush as possible, because if you don't cut these little pigtails off flush and you run your hand across or your finger across, it will cut you if you leave a sharp edge there. And that's why I like these wire cutters. They have that little angle on them, and I can get nice and flush to anything I'm cutting, right even to a circuit board level. Not that I'm cutting anything off of the circuit board. Now right down here on the motherboard, there's a gray fan connector. Let's see if we can get you zoomed in here. That gray one, at least on this model of motherboard from this manufacturer, represents your CPU fan. If nothing's plugged in there, your system may not boot for fear that you don't have a fan running, and it's protecting itself. The fan connector itself has little grooves on it, so it'll only plug in one way, and those little grooves go around that little plastic piece that's standing up. Right there's a plastic, like a little wall, and there's ridges that hug that wall. They go on each side, just like that. Oh, well, how well you can see that, but let's see if we can even zoom in closer. That's as tight as I can get. So yeah, there's little ridges on each side, and that's a 4-pin fan connector and a 4-pin plug, and that's how you know which direction it goes on. All right, so now we can take the RAM out of the package. Okay, we take the RAM out of the package here. I don't need the package. Now, because we have 4 sticks of RAM and we've got 4 RAM sockets, we're just going to fill them all. There's no particular order. I recommend you start on the inside and work your way out, just because if you start on the outside and work your way in, you're painting yourself into a corner. You're making everything tighter. So we're going to open up these little retention brackets on both sides. All right. If you're taking RAM out of a package and it's tight, bend the package to get the RAM out. Don't bend the RAM out of the package. Now this RAM's in here pretty loose, so it's not a problem with this particular packaging, but other RAM manufacturers use different packaging. You don't have to take the little protective tape off of the brand logo, but my OCD requires me to do so. Again, something the customer will never see. There's a little cutout in the RAM, a little notch, and there's a notch in the socket. The RAM will only go in one direction. It's not going to go in this way. It has to align, and the way we're going to put that in is we find the track, find the groove in the track, straight up and down, and it should slide without any force. Make sure that the notch aligns with the groove. Now we can apply a little force with our thumbs, going to one corner and then the other corner. You hear it click on each side. We're going to repeat this exact same process with each memory module remaining. There we go. If you want to fill all 4 RAM sockets, it's best to get a kit of 4 because they've all been tested together. That's not to say that putting in a pair now and a pair later won't work, but it's possible it won't. It's not possible that this won't work. It's all been tested to work together. So there's just peace of mind, and one and done. We're no anxiety. It's nothing we ever have to revisit. The RAM was all tested to work together and is compatible with each other. So in all likelihood, you can put another pair in later without a problem, but there's a potential there could be. There's no potential here, so that's all. One more to go. All right, let's see if I can get that sticker off of here. Come on. Now this RAM has a big heat spreader on it, so you can hold it anywhere as long as you don't touch anything gold. Don't touch the gold. Once again, even if you feel a static shock go across the surface of the heat spreader, it touches nothing electronic. It's just touching like a doorknob. It's just touching something metal. The static discharges. It doesn't cause any harm. Okay, last module. Here we go. That's 64 gigs of RAM, 9900K, Mugen 5 cooler, and 1 terabyte of super fast storage right underneath there. You see why you want to get that one out of the way? You see what I'm saying? Getting that storage drive in or out later, heatsink is a little over it. It makes it difficult to get to. This is an EVGA power supply. I use this for testing and things like that, and I just literally took it out of the box. And I'm going to go ahead and plug in the 24-pin power connector here. All right, so put that down there. Now we don't have to use, on this side of the motherboard over here, I mentioned these two, even this camera can't film it. Let's see if we can twist this around. There's 2 connectors right here for what we call EPS power. This provides power to your CPU, if I can get this twisted around. Now usually your motherboard either has one 8-pin or one 4-pin. This one has both because it's for overclocking and people will draw more voltage to get that overclock. We don't need to use both of these because we're not overclocking. So I'm going to use the 8-pin connector. And most power supplies typically only have one 8-pin connector, and it splits into 2 4s. So if you have a 4, you can use a 4, and if you have an 8, you push them together. And this is labeled as CPU. The clip goes on the outside, and it'll just go on right like this. Maybe. There it is. There it is. So I got that out there. That's what that looks like. Is it dark enough for you? Come on, Carey. Yeah, not difficult to film at all. Super easy. So the power switch and the reset switch are the same switch. It's just depending on where you plug it into the motherboard that determines what it controls. So I'm going to take the switch and I'm going to plug it in to the second pair of pins from the left, top left, right there. I need to hook video up. Now this CPU has a built-in graphics card, and so we're going to plug into that. Now, I have to give power to the power supply. Make sure the switch on the power supply back here, the switch right here, make sure that's in the off position. So we have a standard power cable here, and we're going to plug that in like so. Now we can flip the switch on. You'll see the motherboard blink there for a moment. Okay, here's where it's going to get fun. Here's a mouse. I'm going to come stand over here, away from the fire. Okay, so right now you're seeing a video that says no signal on it. That's your monitor saying it doesn't have any broadcast signal from the computer. So if I put this right here, so now you can see me, so you know the video hasn't gone dead. So I'm going to reach over and I'm going to power this on. right, so now my videos are all on the way. All right, so we're going to turn off the 2 secondary cameras momentarily so we can take a look at what this says. This is our BIOS of the system. So my BIOS version says it's F10. On a Z390 Aorus Pro Wi-Fi, what is the latest BIOS? I like to update to always have the latest and greatest. So what I will do is I will go to Google and I will type in, where's my keyboard? Got to use the right keyboard, Carey. Aorus Z390 Pro Wi-Fi. And then I'm going to click on support. Now you guys can't see this because I'm on the streaming machine. I'm vocalizing what I'm doing, and I've demonstrated this in other videos. But once I'm on the product page from Gigabyte for this board, I go to the support section, go down to BIOS, and see what the latest version. So it's showing me the latest version is F12A. That's 2 versions newer than what we have. Now you don't have to download the latest BIOS. I like to do it because I don't want to have to fix something later on. I'm going to just plug this in to the motherboard here. Now sometimes you need to reboot the system for it to recognize the flash drive. Other times you don't. So let me just take a look and see if it recognizes the flash drive I just plugged in. And do give it a minute, you know, to handshake and acknowledge that I just plugged a flash drive in. So let's get these cameras out of the way. And let's go to Q-Flash right down here. In the bottom right corner it says Q-Flash or F8 on the keyboard. Update BIOS. It does see the flash drive that I plugged in. That's our 12A. See the 12A at the back? And we'll just double click on it. It's reading the file. This, what you see in yellow is the default. That's what we want, the default here. It says intact. So we click on that. Now you can see in the upper left corner, it says current flash, model name, Z390 Aorus Pro Wi-Fi, BIOS version F10, BIOS date 6/5/2019. If you look in the center of the screen, it's finished. It's going to automatically restart itself. And all we have to do is continue to not touch it. I know it's silly that you have to instruct people to leave it alone. But if you just leave it alone, your success rate of flashing a BIOS will skyrocket. And it won't be so scary anymore. Now you'll see it's off for quite a while. Leave it alone. It will eventually come back on. It shouldn't take more than a minute. However, you'll see the screen flash. I can see the fan is running on the motherboard. Here we go. It's already starting, and it still may not be done. It's still not okay to touch anything yet. See, it just shut itself off again. This is normal. It just turned itself back on again. This is normal. It could do this numerous times. All of that on and off, on and off. It's doing that all on its own. Now we're back into the BIOS. It looks a little bit different because it's a newer version. Here on the left side, it says DRAM status, and it's showing our installed memory. And it's showing the CPU fan is running. It sees the Samsung SSD 970. And if we go back to the BIOS settings, let's go to advanced mode. System information. Our BIOS is now F12A, dated 11/29/2019. We now have the latest BIOS version. It wasn't scary at all, was it? Yay, we did it. Now, we can install Windows 10 on this out of the box if we want to. This is a flash drive. I like to use these SanDisk Extreme USBs. They are expensive. They are fast. I need to get a lot of work done. Time is money. So this is a 16 gig flash drive that sells for $20, but it's fast. I'm going to go ahead and plug the flash drive in over here. Well, we're done with the BIOS. Let me turn this off. We're going to turn this off. I want to put the fast flash drive into a fast USB port. The fast USB ports are blue, so anyone will work. And I shouldn't have to change anything in the BIOS. There's nothing I should have to manipulate or alter. All I have to do is turn the machine on, and it will automatically scan to see what it can boot to. Is there a DVD or a CD, or is there a hard drive? is there a flash drive? It will work its way through until it finds something to boot from, and it will automatically boot. Let me show you. I'm going to turn this on. There we go. Fan is spinning. Lights are coming on. We should see something happen here. And I'm going to shut these other two cameras down so you can watch. There's the little circle-y thing. He is a tech. All right, and then this is all your standard Windows installation stuff here. So we'll just go over and click Next and Install Now. Now, when I install Windows, I never enter a product key during installation. Never, ever. You can if you want to. I don't do it that way. So when you say I don't have a product key, be prepared to tell Windows which version you want. Because if you select a version that your product key isn't for, then your product key isn't going to work. And you'll have to reinstall Windows again. So I'm going to select Windows 10 Pro and click Next. There's going to be an end user license agreement. I'm sure everybody reads that. It's a real page turner, little twist at the end. And we hit Next. And we always choose, I always choose custom install on a fresh, clean install of Windows. I want it custom. And you'll see I only have one choice of where I can go. So even though Mike Smith is going to add 3 more drives to this, even if Mike had sent me those drives, I wouldn't be doing anything any different at this juncture. At this point right now, I only want 1 drive attached, and that's the drive I want to install Windows to. That's the only option I have, so all I have to do is click Next. Now, Windows is going to automatically partition this drive and format this drive and install itself. All we have to do is sit back and wait. It's super easy, super easy. All right, now that Windows has loaded, now if I want to connect it to the network, I can. Now watch what happens when I connect it to the network. We'll go to my guest network here. It says, let's finish setting up. It wants me to create that Microsoft account again. Watch. Well, now that you got that internet connection you said you didn't have 5 minutes ago, but right back down in fine print in that lower left corner, hit skip for now, unless you want the Microsoft account. And now we can go to Windows Update and start grabbing all the updates. What I've installed is Windows 10 version 1909, which as of December 10th, 2019, is the latest build of Windows. And I can eject the flash drive while we're waiting. And while I could just yank the flash drive out, I prefer to eject it first. So here's the system running behind me. You can see the fans are running. It's perfectly silent. I can take my microphone. Where's my mic? Take my microphone off. Put it right over here. I mean, I can't hear a thing. I think Mike is going to be a very happy camper. Okay, so there's no more updates. Now what I'm going to do is I'm going to take my utilities flash drive and I'm going to plug that in. And we can run a couple benchmarks. Let's see how this Samsung drive is performing. And let's make sure that the latest firmware is installed. We're going to put the Samsung NVMe driver on the system, and then that's going to require a reboot. So if you have a Samsung NVMe drive, then you're using the Microsoft NVMe driver by default. Nothing wrong with that. The Samsung driver is more optimized. Once that driver gets put in, it can't take effect until the previous NVMe driver is disconnected. And it can't do that while the system is in the operating system, because the operating system needs it to work. So what it has to do is it restarts the system, and when it restarts, then it loads the new NVMe driver. So now we've got the Samsung NVMe driver, or we should. And now I can load the Samsung Magician software. Now you'll notice the Samsung drive didn't come with any software. You have to go to Samsung's website to download it. Because I do this so much, I've downloaded it and kept the files, so I don't have to keep re-downloading it over again. Whoops, English. And again, because it's a super fast flash drive, I can load the files right off the flash drive. I don't have to copy them to the desktop first. So we go to drive details, and it'll tell us firmware is the latest version, and the NVMe driver is Samsung and not Microsoft. We are in PCIe Gen 3 x 4, which is the correct performance interface. Our temperature is normal, and drive health is good. So that's all I need from this. There's other stuff in here you can play with, but I'm going to leave all that for now. I'm going to go back to my flash drive, and I'm going to grab Crystal Disk Mark. I always use the portable version of that. Just Google Crystal Disk Mark, and there's a zip file you can download where you do not have to install the software. You can extract it into a folder. Here's Crystal Disk Mark Portable. This should be the latest version. I'm going to copy it off locally. Not that I have to. And we'll run Disk Mark 64. Remember, Mike will be adding a GTX 1060 to this, and he's also got a couple SSDs and hard drives he's going to add when he receives it. Barring that, everything else will be the same. This is super easy, though. I mean, you know, it doesn't take very long. There. Let's put our power supply in. The power supply we're using is the RM750X from Corsair. Documentation. Big old power cord. We've got some nylon zip ties, a Corsair Go Faster sticker, and black case screws. That can go over there, over there. This we'll put back here. It's like a magic 8-ball. Throw that over there. Silica packet. Do not eat. Power supply. I'll give you a nice close-up on this power supply here. It's a little larger than the standard power supply. Beefy, heavy. There's no sticker to remove because the logo is behind the grate. We've got a warning label on here that says, let's read it together. Silent operation at low to moderate loads. In this mode, the fan will not spin. In other words, don't call us telling you, support. Oh, my fan's not spinning. It's not supposed to. It's to keep it quiet and reduce the dust intake. Intake. And the last thing in the box we've got is the bag of cables. Motherboard, SATA cables, all that's right in there. And this can go right there. All right, let's get this power supply put in. Fan faces down, fan draws air in. So to mount the motherboard, I have to lay the case flat. It's a difficult thing to film. Even when Mitch is here, we have a difficult time filming it because it's dark. And when I put the screwdriver down, it covers up the whole area underneath the screwdriver that I'm tightening down. But what I'm going to do, this Corsair 200R already has 9 standoffs pre-installed in the case, and they're already in the correct position. So I want to get to the screws, which we have here, and I want to pull out 8 of these little tiny coarse threaded screws. There are 2 bags of tiny screws. And one has a fine thread and one has a coarse thread. The fine threads are used for like a DVD install or like SSDs. The coarse threads on the Corsair cases are used for motherboard mounting and 3.5-inch hard drives. 2, 3, 4, 5, 6, 7, 8. Okay, so what I'm going to do is I'm going to plug these 2 EPS power connectors on, and then I'm going to mount the motherboard onto the standoffs. The I/O shield on this board is already here, so it's a super easy install. I'm going to lay the case flat. You see I'm holding the board by the heat sink, so we don't have to worry about any anti-static discharge occurring. Or rather, if it does occur, that it's not going to be touching any components. And I've got to figure out a way to lift the board up enough to plug these connectors on. Actually, I'd like to put it on the cardboard of the box. And I know this is something that's just, it's hard for me to show it to you, but it's also hard for me to do. This is where Mitch would earn his money, where he would earn his nickel, if he's still in there. So I'm going to put on that little 4-pin connector first. Gotta have more slack. Oh, you know what? I'm going to grab a nylon zip tie and tie that back now, because getting to it later will be darn near impossible. So let's just tie that back right now. All right, now let me plug that in the board. I need a little more slack. And I need about a ton more light. And some glasses and another pair of hands and a camera operator and $1 million. Yeah, look, I did it without all that stuff. See? Now we'll put the 8-pin connector on next to it. Now I can pick up the board, put this box down, and I need to pull these cables back through as I lower the board at the same time. And it's sliding off the Lazy Susan here. This rear fan, make sure the cable's out of your way. Move that out of the way. And then let me turn this around. Maybe you can get an idea of what I'm doing here. Somebody ought to. And there's a rectangular cutout here, and I need this I/O shield to fit in there. And I need that middle standoff, which has a post, to go through the center hole on the board, and it'll hold it in position for us. Well, I'm also making sure I'm pulling away any slack on these cables. That'll prevent the motherboard from sitting flat, and making sure that the fan cable that powers this fan doesn't get caught underneath the motherboard or otherwise make the motherboard installation difficult, requiring us to pull the board back out, free up the cable, put it back in again. Trying to do it right the first time, I can't emphasize how much more pleasurable that is. So let me just make some adjustments here on the board, see if we can get that to line up correctly here. And that's it. It's seated down. Fan cable is free. These cables are good. Now I'm going to use my screwdriver to put these 8 screws in. The screwdriver's got a torque setting of 3. Now, if you're a novice builder, you should be turning these screws by hand. It's okay to use an electric screwdriver to take screws out, but it's very easy to cross-thread, over-tighten, or otherwise damage the screw head because you just want to be lazy. Ooh, it looks like I got a lot of spare cable there. So what I'm going to do, I've got enough I can pick the case up, and maybe you guys can get a better idea of what I'm doing here. Let's pick that up. And I want to pull any slack up through here. Oh yeah, okay. I was thinking it was, I was thinking there was extra cable up there, but I was looking at the fan cable. So that is what it looks like. I got 2 more screws to put in though. And these are a little difficult to put in because this is a 6-inch extension on the screwdriver. The screwdriver doesn't come with this bit. I buy these on Amazon, and the parts for the driver, for this Lazy Susan, for these bits, they're all in my Amazon store in the link below the video if you're curious where I get them. But even this may not be long enough to get down in there, especially in that side right there. Yeah, perfect. Now I can go through the rest of them and tighten them. So that's the first one. Remember, there's 8. 2, 3, 4, 5, 6, 7, 8. Boom. So the 2 CPU power cables are here that run out through this wiring hole in the case. Enable us to hide the cables so the computer looks better. And it's going to be easier to work on. Even though this case doesn't have a case window, having cable management done not only makes it look better when somebody does take the side panel off, but if you ever have to work on it, upgrade it, repair it, the cable management, clears all that stuff out of your way so you can see what you're doing. And it may not be something you need right away, but when you do need it, you'll be glad. On the back of the power supply, these 2 connectors right down here at the very bottom are for the CPU power cable. It doesn't matter which one plugs in when. I am trying to find the best way the cable looks to determine which cable I want to plug into which connector. Technically, they both are exactly the same, but what I'm looking at is I don't want these cables. You see one cable's kind of on the outside and one's on the inside, and you see how they just crossed? That's exactly what I was trying to avoid, is these cables crossing like that. So I have to, at the very least, unplug and take this around the other side so it's not crossed anymore. Again, it doesn't make any difference in the operation of the computer, but when I go to tie up the cables and make it look pretty in the cable management part of the build, I want these cables to be tied side by side, and they're going to go all the way off to the side like this. There's little hooks built into the motherboard tray here, and we'll put some nylon zip ties and we'll get that tied up and out of the way. The next cable that I've got to put in is the main motherboard power cable. There's no other cable that looks like this. And on a modular power supply, the opposite end is split into 2. That's the part that goes in the power supply. And these connectors are unique sizes. These are the only connectors anywhere that are shaped that way. So they only plug in one place on the back of the power supply. Super easy. On this power supply, that's going to be right back here and here, just this top right corner. And it's very dark in here. It's difficult, working in the case to demonstrate to you guys fully. So with that cable plugged in, I need to take it right here. Now I could just run the cable right there. It's done. But I want the cable management on this to look nice and clean. And that's what these holes are for in the back. They're there for you to use at your discretion. And so we're just going to slide that through. And we'll pull this through the other side. Make sure we get all the other cables out of the way so they don't get tangled up like this. And we'll just push this right through here. I think that'll be good. And we'll bring this around. And this connector only goes on one way. There's a little clip on it that's going to go towards the edge of the board. And we're just going to align it with the socket, which again is extraordinarily dark, even for me to try and see that. And I can't tell what the camera can see right now, but it's at least there's nothing in the way here, like with the heatsink and stuff. You got a lot of room to get in here. And the cable is a bit stiff. It's not as flexible because it's got 24 wires running through it, so you got to move all 24 wires at the same time. So that part of it remains a little bit of a struggle. It does only go in one direction. It's one of the easiest cables to plug in because it's so obvious where it goes. And what I do is once I get it lined up with the socket, there it goes. No, no, maybe not. Once I get it lined up with the socket, come on, socket. Socket to me. There it is. Boy, that one was tough to line up. They're not usually that difficult. Right now, that's not fully plugged in. Okay, so right now I've got it seated in the socket. Now I'm going to kind of wiggle and push at the same time, and we might even hear the little clip click. Yeah, there was a little click. And then I give it a light pull and make sure it doesn't fall out, because that would suck if it fell out during shipping and Mike gets it and won't turn on. I don't want my customers to have to fix a computer I just built for them. This motherboard comes with the G connector, and that's this right here. And the G connector is this little plastic piece that we can hook all the front LEDs and switches onto. And then we just have one connector to push on the motherboard. We're still hooking up the same connectors in the same place, but what it means is in the future, if we ever have to disconnect it, reconnect it, we can just pull one connector. It makes it easier to work on. And it's an option to use it. You don't, if you want to use it, use it. If you don't, for me, it's basically the same amount of work. You know, like I said, I'm still putting the same connectors in the same place. It's for future work or upgrades to be able to just quickly remove it or put it back on. And we're only using, so if we look at this, I love how this camera focuses. It's fantastic. Oh, somebody needs a manicure. Okay, so on the, let's see if you're watching this, on your right side it says power LED and then PW. So PW is the power switch. And then the rest of that we don't use. If I hold it still, the camera should focus. And then we'll flip it to the other side. And so directly behind the power LED and the power switch, you will see the hard drive. It says HD and RES. And you'll also see it says power LED again all the way on the right side. So the power LED on the right side is for the same power LED, but it's a 3-pin instead of a 2-pin. Some motherboards, not really today, but back in the day, some motherboards had a 3-pin power LED. So the only part of this connector we're going to use is right there, and then on the other side, that's the, if I can hold it right, it's weird to do this in the camera, it's backwards. Right, so that side and this side, it's just 4 wires going into this corner. And the rest of the connector remains bare. And that's going to be pretty much every build. Every modern build within the last 15 years, you're going to use those connectors in the same order, in the same position. And to use this, it's quite simple. This one, if we start with the hard drive LED, it specifies positive and negative on it. And on a Corsair 200R case, we want the HDD LED printing side to face the same print here. That puts that positive cable in the corner. Let's see if I can zoom you in here. I'm just trying to think of a way I can get this closer for you to see. Next to that is the reset switch. So if we look through these cables, we'll find the one that says, oh look, I just grabbed it. Lucky first grab. So that says reset switch. Now it doesn't matter if we plug it on this way or turn it around the other way. Either way will work fine. And it goes right beside the hard drive LED we just plugged in. And there's a little clip and you can hear it. And I can pull on it and it's locked in. Now we're going to turn this around. And it wants the power LED, again, with the positive cable closest to the edge of the connector. So here, I'm going to grab the power LED. And we want the positive cable to the edge. The power LED is split. Now, because this is split, I could theoretically place it to the optional other power LED on the other side, if the motherboard supports that, and most do. But I like to keep all my cables together for cleaner cable management. So we'll just keep it all together. And that means I have to, in fact, that's why this cable is split. Because not only do some cases have 3-pin connectors on their power cables, some motherboards, back in the day, I haven't seen one in a long time, only offered a 3-pin power LED connector on the motherboard. So for compatibility reasons, typically the case and the motherboards now offer 2 positions for your power LED. Kind of silly. They couldn't decide on a standard, I guess. I don't know what's going on with that. Okay, so I need the positive cable. One of these has a little plus. Again, hard for me to show you. And one has a minus. So the plus is going to go towards the edge. I have to squeeze them together. And they're going to slide into the connector. Push down, and I should hear a click. And I tug on it, and if it comes out, I obviously didn't put it in all the way. The last one we've got to hook up is the power switch itself. So once again, with power switches, it doesn't matter if we plug it in this way or this way. I like the writing to face out. Now, instead of having to plug those individually onto the motherboard, when I run this through there, turn this case around, right down here in this lower quadrant on every motherboard made in the last 20 years, this is your front port I/O. And again, we're not using any of that. We're just using that. Sorry, right over here. We're using the top 4 pins and the bottom 4 pins on the left side. That's it. Everything else we're not using. And so, you saw how much light and freedom I had to locate positive and negative, you know. Once you're down in the case and it's dark, and sometimes it could be a little crowded in there to get your fingers in, this connector makes it a lot easier with the cables all facing the left side. It's just going to plug right onto that connector. I give it a little bit of a wiggle, and I push on it at the same time until it bottoms out. We'll take the spare cable and just push it out the back. Real easy. What we just did right now, we just hooked up the power switch, the power LED next to it, the reset switch, and the hard drive activity light next to it. Now we can hook up the USB and the front port audio, and that is in these 2 cables that remain. This flat ribbon cable, well, ribbon-like cable, this is our USB 3.0 front port on the case, which, if we look, bring the case back around and we look at this motherboard, you'll see it says USB 3.0 right here. Some more fancier motherboards, more expensive boards, may have another one of these connectors. Some motherboards have 2 of them. So if you have multiple USB 3.0, like you might have a case with 4 connectors on it, or you could have some other USB 3.0 add-on. If that's required for you, watch for a motherboard that offers it. So if I just bring the camera down just a little bit, you can see it says USB 3.0 in this connector. There's no other connector that looks like a USB 3.0 connector. There's no place else it'll fit, and it only goes on in one direction. When I tell you building computers is easy, I mean it. It's easy. So we're going to bring the USB 3.0 cable through here. It has a notch on one side of it. There's a little notch on it. And that's going to line up with the little groove. And we just push it straight on. We're going to first align the pins with the holes in the plug. So be real gentle at this. And you'll feel it when it's aligned. You'll feel it start to move forward. Right there, I can feel it. Now I can push down, and you often, not always, but often you'll hear it click. Yeah, that one didn't click, but that's plugged in. Now, I do wish that they had a better means to connect this that would lock it in place. Because if you do your cable management too tight on this, it'll pull it right off of there. So when I cable manage this, I always make a little loop here, and I'll do that later, so that there's some slack on this cable. I know that the instinct is to hide this cable as much as possible, but then you put so much pressure on the connector here, and it's so big, it often will pull it right out of the connector. So just be aware of that. Maybe just give that one a little bit of slack so it's not putting too much pressure on there. Now finally, the last connector we have is for the front port microphone and headphones. And again, it's a unique looking connector. No other connector looks like this. And thankfully, it's already, all the wires are already put into the connector for you. And so you don't have to worry about which wire goes where. But you'll notice right here, we get a little zoom in on that. Oh man, I love this camera. All right, so you notice that that pin right there is blocked. That prevents you from plugging it in this way because there'll be a pin that's going to hit. It won't go on. Now this particular connector on most modern motherboards goes down in this, somewhere in this corner on most motherboards. Now looking at this board, if we look really closely at it, let's give you a zoom in on the bottom. Right, bring it down here. If you notice, right next to where all these red, I don't know what these are called. Someone in the chat room will probably tell me what the electronic part is that these red things are. Not transistors. Anyway, right there it says audio. I can probably zoom that in a little bit more for you. See, it says audio. And if you look real closely at the bottom row of pins, you can only count 4 pins because the second one from the right is missing. That's how we know how to orient the connector. So what I'm going to do is just, again, find a hole to bring this cable through to try and hide it as much as possible. This is the worst cable to try and hide because it has to run to that bottom corner. Like if I zoom this out, I can give you a better example of what the challenge is here. When I need to run this cable, this is our last front port audio cable, I need it right here. But the motherboard's in the way to sort of, drop it down. Sometimes on a shorter power supply, I can kind of squeeze it in a little gap right here, which helps. But I'm going to have to go into this main wiring grommet here. And I just have to figure out if I want to go above these cables or below them. I think I want to go below these and above those, I think. You just look at it and see what looks right to you. Let's see, I'm going to bring it in like this. And then it's going to run the length of the bottom of the board. I kind of wish somebody would have a little clip right here on the top of this clip that holds the power supply down. It'd be nice if there's a little clip that holds the audio cable down. Somebody should invent that. There's my $4 idea. Anyway, all I got to do is make sure that blocked pin is on the bottom and line it up. Again, when you line it up, you'll feel you'll feel all the pins go into the holes. And then, and only then, wiggle it back and forth and at the same time push on it towards the board until you feel it hit the bottom. There's nothing holding it in. There's no clip. There's nothing to click. It's just a tight fit is all it is. And then when I do the cable management, I'll pull the slack on that, but it'll always sort of look just like that. And just to give you a zoom in on that, to give you an idea what that looks like, on every motherboard I've worked on, that audio connector is somewhere in this section of the board. Just like these front port switches and LEDs are always in the right side. Now, if you're using a mini ITX board, that's a totally different design. But on ITX and even micro ATX, did I say ITX? On ATX and even micro ATX systems, this layout is pretty well industry standard. There's probably a few exceptions out there somewhere, but if you're sticking with the main motherboard manufacturers, it should pretty much replicate what you have, if what you have is in the last 10 years. Now, I am going to hook up the front and rear fan. That front fan the rear fan is going to be difficult to get to because the pin is way up there. And so what I will do to make my life easier is I'm going to take the fan out. It's 4 screws, it's super easy. I'm going to need some wire cutters. And the reason I'm going to take the fan out is I need to do the cable management on it right now. When you put your fan back in, these screws are not supposed to be super tight. There's little rubber grommets in here, and they're to reduce the noise of vibration. And if you tighten the screws too much, you squish those little rubber grommets and limit their ability. They need to be flexing. Flexing? I'm reluctant to use the electronic screwdriver to put this fan back in because I don't want to over tighten those. I don't want to squish down those grommets too much. So we'll put this in. I like the logo to face up, and I need that cable coming out in this direction because it's going to go straight across. So think about that when you're putting your fan in. It's more important to me that the cable is in line with where it's going so it doesn't have to wrap around the fan at all. If it wraps around the fan, it's often going to be having some slack that through shipping the cable could move and then interfere with the fan. So in this case, this facing straight up, it's going to be hidden. That's sort of a secondary thing for me. But it works out perfectly that when that's straight up, that cable's coming out exactly where I need it to go to connect basically right up here on the other side. We want the supports facing this side. This is the side that's drawing air in. We want air to blow out here. So with this label that doesn't move. See, if you're looking at, if there was a label here, it would be spinning with the fan, right? So that's the easy way to know. That's the side that's sucking air in. This is the side that is pushing the air out. So we're just going to grab one of the screws that we removed and put it right back the way we found it. Only now, it's one less cable I'll have to manage later. And if you put one screw in opposite diagonal corners, the other 2 screws will automatically align without having to hold it. And remember, I'll keep saying it, do not over tighten these. What you'll end up doing is you either push the little rubber grommet out and you'll potentially lose it, or you may have a weird vibration from the fan, especially if it starts spinning up really fast. So the minute I start to see that grommet start to squish, that's where I stop. That's tight enough, that fan's not going anywhere. That fan connector is way up there. It's really hard to get to. There are other fan connectors around the board, and I can use those if I want to, but I just think for cable management purposes, it's nice and hidden and tucked away back there. So I'm going to use these forceps, and I need my flashlight so I can see. And I need to see if that connector goes up or down. Okay, so the grooves have to go up. And of course, because it's cable managed, the cable's a lot stiffer, a little harder to maneuver. I just need to line it up, and then it seats flat down on the motherboard. Super easy. Now, we've got everything hooked up with regards to power, USB, front port audio, this rear fan. We have the front fan to hook up. And I won't cable manage this one because when I do all the cable management, this will be part of that. And so again, I'm going to remove the wire tie, and I have several locations to choose from on this motherboard on where I want to place this fan. And if I look in here, just to give you an example, I can run this fan cable up here. There's 2 fan connectors up here. I typically like to run it down here since I have a bunch of cables down here anyway, and it's a pretty short distance. There are 3 fan connectors right down here on the bottom, and I'll give you a zoom in on that. Right there, you see the 3 fan connectors. 1, 2, 3. What I do is take the fan power cable, and I get it all straightened out, and run it down through the same area down here. And I want to plug it in closest to all the other cables. It's going to go on just like that. And you'll notice that is a 3-pin fan connector going on a 4-pin fan header. You can put a 3 or 4-pin fan, and I've got a video that explains what the difference between a 3 and 4-pin fan are in the quick tips. Like I said, I will have to add some more cables for Mike to hook up his hard drives and solid state drives and optical drive and then power for his graphics card. But I'll do that when I do the cable management. For now, this build is essentially complete aside from making it look pretty. Assuming I haven't damaged anything or accidentally knocked a plug out, the only way to know is to test fire it. So we'll do that now. So this will be our second test fire. We test fired it before when the case was out of when the motherboard was out of the case, and we installed Windows 10 on it and ran, I think we ran Prime 95 on it for like 20 minutes. I think it's just super cool. This time when I turn it on, I should see this fan run, that fan should be running, and then we're going to run it off to your monitor. Okay, I am about to turn it on. Okay. Here we go. I want to see that power LED come on, and it did. I want to see the hard drive LED blinking, which it will do if I hooked it up right once we post. Is it going to post? It's taking an awful long time. There it goes. And yes, the hard drive LED is blinking, so that is hooked up correctly. You'll see this board does have RGB on it if I zoom in on it. That whole thing lights up and is controlled. You can control the color of it. This case doesn't have a window, so we won't be using that. And we've got 64 gigs of RAM in here, and I want to make sure I test this RAM before I send it off to Mike. And I use MemTest86. I have a quick tips video which you can watch on how to download and create a bootable MemTest86 flash drive. This is a small 2 gig flash drive. You don't need much space for it, and you won't be able to use the flash drive for anything else. So just bear that in mind. You can use any size you want, but that's all it'll ever be used for. So what I'm going to do now is I'm going to shut the machine down. Front fan is spinning, rear fan is spinning, everything's good there. You see how fast that shut off? Now I will plug this MemTest86 drive in, turn the machine back on, and I'm going to press F12 for Gigabyte motherboards. Hit F12 on the keyboard. You'll see at the bottom middle it says F12 is the boot menu. And we should see that flash drive right here as a boot option. And then I don't have to touch anything else. All I have to do right now is be patient, and MemTest86 is going to load and configure itself, and it has a little timer to count down in case you want to modify anything. I suggest just leave it at all the default values, hands off, and it will start itself and start running a series of tests on the RAM. And again, just because MemTest86 says your RAM is good isn't a 100% guarantee that your RAM is good. But if MemTest86 says your RAM is bad, you definitely have some bad RAM. So just bear that in mind. And you'll know it. If you see errors on MemTest, you'll know. And watch the MemTest86 video to learn more about that and what to do about it if you have errors. Many of you watching have some bad RAM in your system and you don't know it because you haven't hit that spot of the RAM yet. You're not fully using the RAM. That's why it hasn't impacted you yet. So it's a nice peace of mind to run this on your system to make sure that everything passes the way it should. And so we're going to do that now, and it's going to take a while to test all 64 gigs. It's going to take quite a while, probably 2 hours, hour and a half, 2 hours. So we'll let that run. And that completes also the mem test. Just finished pass number 1 with no errors. So what I can do now, like I said, you don't have to properly shut down the computer. I can just reach around back, flip the switch off, and remove the flash drive, the mem test flash drive. And I know confidently that this computer has 64 gigs of perfectly good working RAM. That's pretty much it. It's ready to rock and roll.
Hi everybody, I'm Mike Smith, host of the Mike Tech Show, and I am now opening the beast which Carey built for me. So bear with me, as this was very well boxed and just arrived actually a day early. So I am excited about getting this going and all the next shows. So we are literally unpacking this. My son Michael Jr. is the cameraman, and we got a lot of paper. And then if you notice, when Carey was building the box and the system, we have a case of spare parts, and then we have the motherboard box. So we'll put that off to the side. Now I am going to get rid of all of this, and we're gonna tilt it. I'm gonna try to tilt it to the front of the camera. All right. The only way, I think Carey instructed me, was sit it like that and just lift it up. And now, of course, I'll keep this case box, but the packing box we can get rid of. It's actually pretty light, because I have to add a video card and two hard drives and an optical drive. But what we want to do is power the beast up. Starting it up, and it should boot right in. There's the Aorus. Son's gonna zoom in on the screen. It's loading. Mike, it booted. Let's look at the system specs real quick. How's that for a boot, everybody? It doesn't get better than that. So zoom in, and you can see it's a Core i9, 64 gigs of RAM, Windows 10 Pro. I am a happy camper. I look forward to recording Tech Vets and Mike Tech shows on this beast. I will migrate my video card, my hard drives, just a couple drives, and of course I need an optical drive, so I can't ask for more than that. Carey is the system builder god. Thank you so much for my system.